Hello everybody, welcome to Dr.K.Liu Math channel. Today, this question is about the Fibonacci sequence. The Fibonacci sequence is that Fn is equal to Fn minus 1 plus n Fn minus 2. Given F0 is 1 and F1 is 1. F0 is 1, and then found a general expression of Fn. This is so famous about the Fibonacci sequence. This is about the story of the rublets, the number of rublets that in nth generation. But I don't want to talk too much about sidetrack the main problem. I'm here. Want to find the general term of the Fibonacci sequence with the method of diagonalization. Okay, first I have to set up a matrix form of the Fibonacci sequence. Fn is equal to Fn minus 1 plus Fn minus 2, and Fn minus 1 equal to Fn minus 1. This gives a expression Fn minus 1 equal to 1110 times Fn minus 1 Fn minus 2, and then further as this relation can be expressed as this can be further decomposed into a matrix 1110 times and Fn minus 2 and Fn minus 3. The index is reduced one more step, and if one more step a more matrix is coming out. Therefore, this is 2 to the power 2. Okay, and further, I can decompose. A further step here. This is when the power is equal 3. That Fn minus 2 become Fn minus 3 and Fn minus 4. Finally, if we go to the end of the sequence, this is F1 and F0, and the power should be n minus 1. Yes. Why this one? As the matrix power is equal to the index. The sum of these two terms is equal to n. Therefore, if the index, if the subscript is 1, the index should be n minus 1. Then the sum is equal to n. Okay. Next step, I want to diagonalize. Okay, I think F1, I can write down F1 here. Oh, right here. 1110. N minus 1. 1. F11 is here. And for this matrix A equal to 1, the most hardest step here, I want to calculate the eigenvalue and eigenvector of this matrix. A minus lambda I determinant equal to 0. That means 1 minus lambda 1 minus lambda equal to 0. 1 minus lambda times minus lambda minus 1 equal to 0. Expand this and becomes lambda squared minus lambda minus 1 equal to 0. Then lambda has 2 roots, 1 plus or minus square root of 5 over 2. And then for lambda equal to 1 plus square root of 2, the Allman matrix can be written as like this. Okay, and for lambda equal to 1 minus root 2, the Allman matrix can be written as like this. Yes. And for first Orman matrix, I first calculate that here, and this one is 1 minus square root of 2, 1, 1. And here, row 2 times 1 minus root 2 over 2 minus row 1. Then this will become 0, 0, oh, double 0. That means I can let x equal to t, and then y is equal to square root of 5 minus 1 over 2t. Then we have the first eigenvector. Oh, wow. Oh my god, the root is third form, in third form, not a perfect form, not an integer, but third form. How come? But no problem. I think K.Liu can be solved, can solve this problem. For you, yes. Okay, this is the first eigenvector. For the second eigenvector, lambda equal to 1 minus square root, and here, and actually I can do it in smooth way. And next step is row 2 times 1 plus root 2 over 2 minus row 1, and then 1 plus, and this row is all 0. Then here, and let x equal to t, and y is equal to minus 1 plus square root of 2. And for the second eigenvector can be set as 1 minus 1 plus square root of 2t. Okay, then for the matrix A, this one, I can diagonalize this matrix and put the two eigenvector, 1 here, second here, and equal to first eigenvector, second eigenvector, and then times the diagonal matrix. Sorry, so excited. Okay, this is the minus sign is outside the fashion. And then the corresponding eigenvector is this one and this one. And now I multiply this. Okay, I want to copy this one. And move this matrix to the right hand side of the. This is minus and inverse. And the inverse of this matrix equal to, I just copy the solution here. This is minus 1 over root 2 times minus 1 minus root 2 over 2 minus 1, 1 minus root 2 over 2, 1. And then for the power 8, the power n, which should be equal to this, the power of this matrix n to the this matrix power to the n. But fortunately, this form is equal to, actually the power is go into this position, and this is diagonal matrix. This is diagonalization, and the power can be go inside here. Okay, so nice. And then I multiply this format step by step for the first one, which is equal to 1 plus root 2 over 2 to the power n. The second one is 1 minus root 2 over 2 to the power n. This is minus 1 plus root 2 over 2 to the power n plus 1. Oh, let me see. N minus 1, not n. Because this one times this one is, and this is n minus 1. I don't show the step here, but you can check by yourself. And then next step is this times this. This also equal to 1 minus, this times this one is equal to 1 minus square root of 2 to the power n minus 1. And I move the term minus 1 over root 2 to the right hand side, and times this one. And multiply again. Then we can write this matrix as this form 1 1 1 0 to the power n. After finish the multiplication, we have the matrix equal to this one. It is so complicated. When I finish this, I have to check this several times so that I can guarantee the answer is correct. Because normally the problem you see is the eigenvector and eigenvalue is integer or even fraction, but in this case the eigenvalue is a third form. Third form is more complicated. Hope that guys can follow this step. And then finally, as we in the beginning, we have fn minus 1 is equal to 1 1 0 to the power n minus 1 times 1 1. I can go back to this part. Yes. This I just copy to this part, and for this matrix, we can copy this to the next step. But we paste the n here because this is n. I have to replace the n by n minus 1. Okay, I copy here. And change the n to the n minus 1. This is be n minus 1 minus 1 minus 2 minus 1 minus 2, and then times 1 1. This is fn minus 1. Then the general term should be equal to fn is equal to this times this. 1 minus 1 over root 2 times this one plus this one minus this one. Oh, crazy. I can't believe that is so complicated. and these two factorize the common factor and simplify. The result, we actually have minus 1 plus square root 5 over n plus 1 plus, and for these two we can simplify as 1 minus root 2 over 2 n plus 1. This is the general term of the Fibonacci sequence. Crazy, but it is integer. It is integer, but in the format of third form, and multiply the minus sign inside the bracket. This is become positive. This become negative. Okay, crazy. Okay, it is the final step. I hope that you can enjoy this video and learn more about the Fibonacci sequence. Okay, finally, please subscribe my channel. My channel is Dr.K.Liu Math channel. Dr.K.Liu Math channel. Okay, thank you. Bye bye.